Hello student, in next video we discuss mean and variance of binomial distribution. In last video we discuss mean and variance of uniform distribution, and in this video we discuss for binomial distribution. Let x is related to b of np distribution, then mean is equal to e of x, which is equal to summation x px from 1 to n, which is equal to np, and variance, which is equal to v of x, which is equal to e of x square minus in bracket e of x bracket square, which is equal to npx. Therefore, standard deviation of x, which is equal to under root npq, where capital E of x square, which is equal to summation of x square into p of x from 1 to n, which is equal to n into n minus 1 into p square plus np. Note that for a binomial distribution, e of x is greater than v of x, that is mean is greater than variance. Next point, real life situation for binomial distribution. So, these following are some real life situations where the binomial distribution is applicable. Number of male births out of n births in a hospital. Second, number of seeds germinated in a row of n planted seeds. And third, number of rainy days in month. Next point is additive property of binomial distribution. The binomial distribution follows additive property and it is stated as follows. So, statement of additive property. Let capital X and capital Y are independent random variables such that x related to b of np and y related to b of n2p. This is n1p and y related to b of n2p. Then x plus y related to b of n1 plus n2, comma p. Recurrence relation for binomial probabilities. Recurrence relation for binomial probabilities is let x related to b of np, then p of capital X is equal to small x, which is equal to p of x is equal to ncx p raised to x q raised to n minus x, and x is equal to 0, 1, 2 up to n. Similarly, capital P of capital X is equal to small x plus 1, which is equal to P of small x, which is also equal to nc x plus 1 p raised to x plus 1 q raised to n minus x plus 1, where x is running from 0, 1, 2 up to n minus 1. Therefore, P of capital X is equal to small x plus 1 upon P of capital X is equal to small x, which is also equal to nc x plus 1 p raised to x plus 1 q raised to n minus x plus 1 divided by ncx p raised to x q raised to n minus x, which is equal to p of capital X, which is equal to small x plus 1 divided by p of capital X, which is equal to small x, which is also equal to n minus x upon x plus 1 into p of x, p by x. Therefore, capital P of capital X is equal to small x plus 1, which is equal to n minus x upon x plus 1 into p upon a q into p of capital X is equal to small x, where x running from 0, 1, 2 up to n minus 1. This above recurrence relation is useful to find the probabilities of binomial distribution. And for this, first evaluate p of x is equal to 0, which is equal to q raised to n. So, first example, let x follows binomial distribution with parameter n is equal to 10 and p is equal to 0.5. Find p of x less equal 1. Second, p of x greater equal 2. Solution. Given that capital X is related to B of NP, that is n is equal to 10 and P is equal to 0.5. Therefore, the PMF, that is probability mass function of capital X, is P of capital X is equal to small x, which is equal to, we know that the probability mass function is NCX P raised to X Q raised to N minus X, that is NCX P raised to X into Q raised to N minus X, where X is running from 0, 1, 2 up to N, which is equal to N is 10 and CX P is 0.5 raised to X and Q is, we calculate Q is 1 minus P, that is 1 minus 0.5, which is equal to 0.5. So Q is 0.5, which raised to 0.5 raised to 10 minus X, and X running from 0 to 10, which is equal to 0 otherwise. First we have to calculate P of X less equal 1, which is equal to P of X is equal to 0 plus P of X is equal to 1. So put X is equal to 0 and 1. 10C0 into 0.5 raised to 0, 0.5 raised to 10 plus 10C1, 0.5 raised to 1, 0.5 raised to 9, which is equal to, and this is 10C0, this is nothing but NCR. So here take formula for combination and solve it, and after solving this we get 0.0010 plus this 0.0098, and which is equal to 0.0108. Next we have to calculate second condition, that is P of capital X greater equal to, which is equal to 1 minus P of X less than 2, which is equal to 1 minus P of X is less than 2 is P of X is equal to 0 plus P of X is equal to 1, which is equal to 1 minus, and in last condition we calculate P of X is equal to 0 and P of X is equal to 1. So P of X is equal to 0 is 0.0010 and P of X is equal to 1 is 0.0098. So, and addition of this is 0.0108. So 1 minus 0.0108 is 0.9892.